Next on Brute Force, the history of weapons at war. Warfare on the battlefields of the 21st century and beyond. Weapons so smart, they're called brilliant. Pilotless planes that fight with incredible stealth, speed, and agility. They're armor-plated and computer-equipped. From the revolutionary weapons of the past to the specter of directed energy beams in the wars of the future. Next on Brute Force, the history of weapons at war.
Freedom, power, greed, survival, whatever the motivation, man has always devised more devastating means to wage war, from primitive sticks and stones to the flintlock rifle. Each new weapon must have seemed all-powerful when it first appeared on the battlefield. Today's weapons have developed such an incredible degree of sophistication, you have to wonder just how far they can progress. Can aircraft grow stealthier? Can bombs become smarter? Will tomorrow's battlefield be inhabited by robot warriors? What are the weapons of the future?
In January 1991, the world caught its first glimpse of the battlefield of the future, a battlefield forged by a revolution in information. In the night skies and vast desert of the Persian Gulf, a new era in warfare began. Warfare of the computer age. On this battlefield, precision proved victorious over mass. Precision guidance of weapons, precision coordination of the land, sea, and air forces, and precision training of the soldiers charged with handling the new technology. All this was made possible through the use of the microprocessor.
There's considerable development today in the use of computer technology, in the use of microchips, of course, in the use of pre-programmed systems. So what we're seeing is the use of the latest scientific innovation being directed towards the battlefield. The emphasis now is on quality and not quantity. The Iraqis had, on paper, the world's fourth largest army. They were facing a very small army in relative terms with the coalition put into the field. But the coalition had better intelligence, better planning, it had a better will, and it had better training and leadership. Without those, there's no point in going to war.
Computer-aided weapon systems like the Patriot missile, multiple launch rocket system, cruise missile, and laser-guided bombs all had a tremendous impact on the war, striking designated targets while minimizing civilian casualties.
Some of the lessons from Desert Storm have been the value of precision weapons, being able to go in and very accurately pinpoint where the weapon would go, be able to go into areas where there could have been collateral damage if we had not been very, very careful about the placement of those weapons. We were able to take chances in those areas and very effectively pinpoint where the weapon would be going and to do it confidently.
The smart bombs of Desert Storm set the stage for the next generation of precision weapons, which will be known as brilliant. future battlefield, the artificial intelligence of brilliant munitions will allow them to make their own decisions as to what target to strike.
The biggest contribution, I think, from technology today lies in the area of the computer and computer processing. Interior to the missile, with the help of sensors observing the outside world, these onboard computers have brought more and more ability to process, calculate, differentiate, segregate, separate real targets from things that are not targets. What we'd like to do in the next generation of missiles, the brilliant weapons, is to build into them the ability to discern from a number of different potential targets, not only the right object to destroy, say a tank, not a rock or a building, but a tank that belongs to an enemy force that can be distinguished by its shape, its speed, or other characteristics that characterize that as an enemy tank, not a friendly tank. The problems that we have in current warfare are that we have to make that decision as to whether that's truly an enemy target prior to launch. And when you're doing a high-speed engagement against an enemy, you'd like to be able to fire the missile when the conditions are right and let the missile make sure that it's going after the right target, especially if there's a complex scene out there of good guys and bad guys. Kill the bad guy, don't kill the good guy.
One remarkable system under development is the Star Streak. It fires 3 guided explosive darts in each round at several times the speed of sound. The darts will split to engage multiple targets.
The future missile is going to be far more sophisticated than we can perhaps even imagine at this moment. It's going to be one stage further than what we call fire and forget. It's going to be fired off toward a general target area. There may not be a target there for it to go at that time. It will then wait until a target appears. It will hang from a parachute or hover on a sustainer motor or something like that. And once a target, a ship, a tank or radar appears, the computers on board that missile will work out the best way to attack that target, whether it's going to be top attack, side attack. And that once they actually operate and guide themselves in their target, their effectiveness is going to be absolutely devastating.
As we look back and reflect on the Gulf War, I would be surprised if we don't look at a watershed in terms of brilliant munitions. The ability to very precisely put a weapon at a particular place, a particular time, reducing the amount of additional damage there is. Today, we have a situation where it's entirely credible that we could say, if you, nation A, do such and such, we will destroy 100% of your electric power.
With weapons armed with such incredibly independent thinking, one wonders what safeguards will be installed to prevent them from making the wrong decision.
Each time we've raised the level of sophistication of the missiles and made them more autonomous, or more self-directing, self-guiding, the military user has always asked us, shouldn't we implement some kind of a command-destruct mechanism in case this missile makes the wrong decision? That the operator, seeing the missile's doing the wrong thing, could hit a button and cause that missile to detonate in the air and end its mission right there. Usually what happens is, as we gain experience with the newer generation of missiles, we become more comfortable that they're doing the right thing. We learn not only the technology is making the right decision, but we learn operationally how to use it, where we're comfortable using the weapon as it stands. We trust the technology, or we limit its application to where we can trust.
The last great revolution in warfare began with the Industrial Revolution. The internal combustion engine propelled new machines of war across the battlefield and through the skies. With mass production came weapons of mass destruction, weapons that seemed futuristic when they first appeared on the battlefield.
Technical innovation in the First World War on the battlefield was, I suppose, the machine gun, which enabled a very rapid rate of fire to be thrown across an area of land, decimating the human waves of soldiers who came out of the trenches to try and move forward. The tank, used to attack enemy strongholds and trenches. And of course the aeroplane, which took the battle into the third dimension.
Revolutionary new weapons created in World War II set the stage for today's technology. With jet engines, air forces could engage the enemy with unheard-of speeds. With the German V-1 and V-2 rockets, nations could wage war from long range without putting individual soldiers at risk. And with radar, battles could now be waged on the electronic battlefield. In July of 1945, the United States of America began testing a future weapon of unimaginable power. With the invention of the atomic bomb, the face of warfare and the world changed forever. After World War II, weapons development progressed rapidly, coupling the immense power of the atomic bomb with the growing intelligence of the computer.
Okay, will arm agree? I agree, sir. Arm 11-4. Once naval switch is armed, warplane select switch.
Increasing Cold War tensions, along with this awesome new technology, sent the world hurtling towards a future that appeared grim.
But what's interesting is in recent months, it's gone the other way. In other words, from the Second World War until the late 80s, everyone was considering a nuclear war as an inevitability. The Gulf has shown that you can still have potentially a very bloody and protracted war actually being fought with conventional weapons. So there's now a rethink along the lines of what will be the future. I think what we're going to see now happening is there'll be less dependence on nuclear weapons. They certainly have never been a military weapon, but there'll be less dependence upon them being a political weapon.
Brute force, the history of weapons at war, will continue in a moment here on A&E.
A great success story of future technology in Operation Desert Storm was the F-117A stealth fighter.
The result of all the stealth techniques applied to the F-117 was that the first inkling the Iraqis typically had of a stealth fighter being overhead was when the bomb exploded on the ground. The Air Force noted that it was the only airplane over Baghdad that first night. Other airplanes were striking other targets. But for the high-value targets in the center of town, where they wanted to minimize collateral damage and where they didn't want anyone to know they were coming, they used the F-117.
The F-117 is nearly invisible on enemy radar. A layer of radar-absorbing material covers the aircraft. The angled lines and triangular faces of the jet help deflect incoming radar beams. The stealth's radar signature is about the size of a pigeon.
All fighters have always tried to be stealthy. They've always tried to come from a surprise. The greatest number of victories are those occasioned by a pilot who surprises somebody and shoots down the other guy before he knows it. But in the case of the F-117, Lockheed undertook to use materials and primarily shapes that would, instead of bouncing a radar wave back to an enemy radar set, would instead scatter it so that its radar signature is reduced. It defies the old rule that if an airplane looks good, it'll fly good. It is not what any schoolboy would draw as an ideal airplane. Instead, it's got a very angular and unaerodynamic looking shape. It probably wouldn't have been possible before there were sufficient computers to augment the stability of an airplane of this type.
The aircraft must use a fly-by-wire flight control system. In other words, the work once done by hydraulics is now done with a computerized network of electric motors. Fighter aircraft of the future will place great emphasis on stealth and agility. New designs will incorporate these attributes, while existing aircraft, like America's F-16, will be modified.
Radar loves to look into a hole, like a cockpit. And with the F-16, they've given it a canopy which has gold in it, which reflects radar away in all directions off this curved surface, and the radar doesn't see into the hole. That reduces the radar cross-section of the F-16 by a tremendous amount.
The airplane chosen by America to rule the skies in the 21st century is the F-22, Advanced Tactical Fighter. Still in prototype stages, the F-22 incorporates a radically new technique to enhance maneuverability. Special nozzles on the engines direct the exhaust stream to help push the aircraft through tight turns. The ATF will achieve a top speed of over twice the speed of sound. The European Fighter Aircraft, EFA, is being developed as a joint venture between Great Britain, Germany, Italy, and Spain. Today, the EFA exists only in computer simulation. However, an early prototype, known as the Experimental Aircraft Program, EAP, was built to demonstrate the feasibility of the EFA's requirements.
European fighter aircraft is being developed against a quite specific set of requirements, such as it must obviously be supersonic, it must be extremely agile, it must be stealthy to a certain extent, it must have a very capable radar, radar-guided missiles, dogfight missiles, and a gun. It also has to carry bombs and air-to-ground missiles and so on. And it must take off from 500 yards of concrete motorway, the remaining straight 500 yards in a shattered runway. You can't afford to rely on thousands of yards of snowy white concrete any longer. It also, for example, has a number of things on it. Whatever you put on a pylon automatically tells the central computer what that thing is on the pylon, and the computer adjusts itself to deliver that weapon. The airplane is completely unstable and could not be flown by a human pilot without the fly-by-wire system. And it's that instability which makes it so maneuverable. So it has some very, very cunning electronics and computer programming in it.
The Swedish JAS-39 Gripen is being designed as a multi-role aircraft. Air defense, reconnaissance, and attack. A highly computerized design will allow the pilot to switch between these roles from the cockpit without the need of ground preparation. Designs for future aircraft are often developed using test beds, planes never intended for production, only for research and experimentation. Today's fighter test beds are being used for research in maneuverability.
The current fighter buzzword is agility, extreme maneuverability. More than we have seen in the big air shows yet. More maneuverable than that.
The X-29 uses a forward-swept wing design. Compared to conventional wings, forward wings provide high maneuverability and improved slow-speed handling. Forward wing aircraft are virtually spin-proof. The aerodynamic advantages of forward-swept wings have been known since World War II. However, the shape creates tremendous stress on the wings. Only recent developments in strong, flexible composite materials and computerized flight controls have made forward-swept wings feasible.
The X-31 EFM Enhanced Fighter Maneuverability Program is the first international X-plane, a joint development project between the United States and Germany. Victory in dogfights usually goes to the aircraft that gains position and fires first. Computerized flight controls and thrust vectoring allow the X-31 to turn tighter and point at targets more quickly. The goal of this test aircraft is to help design the next generation of air superiority fighters. With almost total reliance on the microprocessor for the flight of future aircraft, careful precautions must be taken to prevent computer failure.
They have a system with 2 computers in it. Now, the computers have the central processor, the processor chip. They use different chips from different manufacturers in the 2 computers so that a fault which emerges, a characteristic fault which emerges in one of them, won't emerge in the other. The boxes and the circuitry are designed first in different companies by people who have no contact with each other in different towns. Those 2 computers, which perform exactly the same functions, are as different as you can possibly make them, so that no single fault can ever migrate into the other computer. That's the kind of thing they do right through these systems.
Brute force, the history of weapons at war, will continue in a moment here on A&E.
The lumbering tanks of World War I were a revolutionary weapon for their time. Throughout the century, they evolved into an awesome technological achievement in mobility, protection, and firepower.
Obviously, technology doesn't stand still. There is always new technology, a new threat. The development of armoured vehicles is often determined by the threat. It is what you think your potential enemy will have in 10 years' time.
Today's main battle tanks, like America's M1A1 Abrams and Britain's Challenger, are equipped with much of the same computer technology of a fighter aircraft. Infrared night vision systems, laser range finding, computer-stabilized guns, and armor plating made of top-secret composite materials. The M1A1's armor includes depleted uranium, a material 2 1/2 times as dense as steel. It is powered by a 1,500 horsepower gas turbine engine and is capable of speeds over 40 miles per hour. In the Gulf War, the Abrams met the Soviet tanks it had been designed to counter. Its performance quieted the many skeptics who believed the complex technology would fail under actual battle conditions.
I've been kind of a lukewarm skeptic about the tank. Because it seems so big and so expensive and so complicated and all, and it probably is all those things still. I mean, it's still big and still expensive and still complicated. But the point is that when it was maintained properly, and when it got to the battlefield, which is the testing ground for any weapon, it performed exactly the way they wanted it to perform. The Iraqi tank force, which had been touted pretty heavily before the conflict began, proved completely incapable of dealing with the situation it was presented with. The effective killing range of the M1 seems to have been so much greater that there really wasn't a contest.
Many advancements in future weapons will rely on innovative upgrades of existing systems.
Today, most tanks have a life cycle of about 20 years. For the first 10 years, they remain the same. Then they have a midlife upgrade, and that leaves them through for the next 10 years. Currently entering production for the British Army is the Challenger 2. Basically, the Challenger 2 is a modified Challenger 1 hull with a brand new turret, with better armour protection, a better gun, and a much better fire control and target acquisition system. And that will come into service with the British Army in 3 or 4 years' time. The first M1s had a 105 gun. The next one, the M1A1, had a 120 gun. The current one, which hopefully will enter production soon, will be the M1A2, which has got the same gun, but a much better fire control system, a better target acquisition system, better protection, so it's more survivable.
The M1A2 has, in addition to the normal characteristics of the Abrams, we put in a commander's independent thermal viewer, which essentially is a hunter-killer, so that the tank commander basically can find a target looking over, let's say, over his left shoulder. Automatically, the gunner sees the same sight picture. He can engage the target. Meanwhile, the commander has moved with his independent means and is looking now over the right shoulder and finds a different target. It means that you can accelerate the engagements considerably.
Future tank designs will place even greater reliance on the microprocessor. One plan calls for interchangeable computer-controlled modular weapon systems that can be quickly fitted to the Abrams tank.
What you basically have in the tank is essentially mobile protected firepower. Really, it's mobile protected space. And the real challenge is, how do you want to use that space? I would hypothesize that the processor should give you the ability to almost interchange the functional use of the vehicle. Well, maybe I don't want to have a CITV, the Commander's Independent Thermal Viewer. Maybe I want to have a millimeter wave radar over here, and I'll have thermal imaging here. Or maybe I want to put a tunable laser over here and keep the FLIR here, the thermal imaging here. Or maybe I want to put some other kind of weapon over here and just drop it in, and the enemy doesn't really know which one has what. And if you're going to face me on the battlefield, because I can replace those interchangeably, and I'm speaking some years from now, you don't know what the mix is. Now, if you can't tell which one has what, I've just made it stealth. Stealth because you can't tell which tank has that terrible death ray or whatever it is that we've managed to develop. Now, what I'm doing is just describing to you different applications of the power that's provided to you by the microprocessor.
As advanced as tanks are becoming, there are still those who argue that it is a dinosaur without a place on the future battlefield.
You always hate to say that something is obsolete because, you know, it's so easy to be incorrect about it. But there are new things that transpired, and the new series of smart weapons, of the shoulder-fired weapons and so forth, the new series of attack helicopters, I think will diminish the importance of the tank on the battlefield, and that you won't see the same reliance placed upon it by the Russians or by ourselves 20 years from now that you'll see placed on it today. There will always be some tanks because you need some to control the street corners, you need some for certain purposes, but they won't be the main armored thrust that they have been for almost 50 years now.
There are many people who have said the day of the tank is over. That was also said in the Second World War and also in the First World War. The tank still has a future. In the future, the tank will look something quite different than it does now. It may have a different weapon system. It may have a different shape, but it will still survive, because although helicopters and air power play a very vital role in any conflict, as they did in the Middle East, it is only the tanks who can take and hold ground with infantry, artillery, and engineer support. So the tank is still the cutting edge. It is still the offensive arm of any army, and there are no signs that any army is yet giving up the tank.
Brute force, the history of weapons at war, will continue in a moment here on A&E.
A major victory won during the Gulf War was conquest over darkness. Night vision systems were first used in Vietnam, but they were highly refined by the time they saw combat in Desert Storm. Systems like Lantern, low-altitude navigation and targeting infrared system for night, denied the enemy the sanctuary of the night. This is a pilot's view in total darkness through smoke and haze without the system engaged. This is the view with Lantern. The system enabled fighter pilots to fly beneath enemy radar in total darkness at speeds exceeding 500 miles per hour and destroy several targets on the first pass. F-15s were equipped with this system in their search for mobile Scud missile launchers. These are the two views a pilot saw during an engagement with Iraqi tanks. On the top navigation screen, he witnessed his missiles being fired. The bottom targeting screen
recorded the results. Like many of the new weapon systems, the complex technology of the Apache helicopter was criticized before Desert Storm. However, the great success of the helicopter in the Gulf War can in part be attributed to its highly advanced night vision and target acquisition systems.
One of the limitations of a battlefield helicopter has always been its ability to operate at night. Today, the modern Army aviator is equipped with night vision goggles, which allow him to see in the dark. He also will be equipped with forward-looking infrared, which allows him and his gunner to see targets, which are picked out by their heat signature against the dull and colder backgrounds of the Earth.
Right there. Roger. Let me go. Good hellfire launch. You got somebody on the ground.
Modern technology now means that an attack helicopter and a transport helicopter can operate with equal ease by day or by night, in haze, in mist, in fog.
A new helicopter being developed jointly by the French and Germans is the Tiger. Still in prototype form, this attack helicopter is being designed in combat support, armed escort, and anti-tank versions. The Tiger will enter service early in the next century. The future helicopter design of the United States is the Comanche light helicopter.
The new technology of the Comanche helicopter is based on modern materials like composites, carbon and epoxy resin that's not only strong, but it's easy to make. It can be bent into conformal shapes to get the best possible airflow, to be able to hide weapon systems, to be able to fit in all the black boxes that are necessary. It's also easy to maintain. The capital cost is quite high, but the overall running costs of the aircraft in its life of, say, 20 years will be low.
The fantail rotor design of Comanche has been tested in sidewards flight at over 70 knots. Comanches are being built to supplement the Apaches on the battlefield, carrying out armed reconnaissance and heavy attack roles.
The British and the Italians have developed the EH-101 Merlin helicopter for use aboard ship. This helicopter is almost a flying frigate. There's no other helicopter to compare with it in the world. It has 3 engines. It has the capability of operating in day and night. When it goes into service with the British, Italian, and later Canadian navies, towards the end of this century, it'll be the most advanced naval helicopter system in the world. The helicopter has the ability to be agile, to use the earth, the folds in the earth, trees, and other obstructions, to be able to sneak up on its enemy, fire its missiles, and retreat.
The helicopter is, in fact, to my mind, it's a very, very high mobility, high firepower, low protection tank.
Since the Second World War, the tank has been considered the queen of the battlefield. The helicopter, the modern attack helicopter, is perhaps the crown princess and going to take over that role from the tank by the end of the century.
Military designers have long been trying to combine the vertical takeoff and landing and hovering capabilities of a helicopter with the high-speed, high-altitude, long-range cruise capabilities of an airplane. The British Harrier proved extremely successful in close air support missions during Desert Storm. Under development in America is the V-22 Osprey.
This aircraft, which developed out of a US Marine Corps requirement to replace its troop-lifting helicopters, is one of the leading edges of technology. Basically, it's the sort of technology that no country can afford to be without. It combines all the values of vertical takeoff and landing in a helicopter with the forward flight capabilities of a turbine-engined aircraft. So in other words, you can take off vertically from the aircraft carrier deck at 250 miles, fly at low level at high speed, and land vertically to deposit troops or equipment in a combat area. It would make marine operations, army operations, so very much easier if it comes into service. Of course, it's new technology and it's expensive, but it's the sort of technology which I think the Americans are going to progress. It's the sort of technology that if the Soviets were still and the Brezhnev era, they'd be throwing money at as if it was going out of fashion.
Like many weapon systems, the fate of bomber aircraft remains in flux due to decreasing east-west tensions and arms control. Of course, one of the most dramatic futuristic designs of any weapon in the world today is the B-2 stealth bomber. Funding for the controversial project has continued, emphasizing a new role. The B-2 is being slated for use in regional conflicts like the Gulf War, not for penetrating Soviet radar during a nuclear war.
One of the new inventions that's coming along and is using the latest technology is the directed energy weapon, the particle beam weapon. We're almost getting into the realms of Dan Dare and Superman with space guns and space rays. We're actually talking about using basic high-energy physics to develop a weapon which doesn't have a bullet, it doesn't have a shell, but uses directed energy to destroy its target. Quite away from development yet, but something which probably will be used in the Star Wars program in SDI in space.
With the easing of Cold War tensions, the controversial Strategic Defense Initiative will perhaps no longer emphasize its original role, the use of space-based laser beams to halt a nuclear attack.
There's some sentiment that you don't really need it anymore because of the end of the Cold War and the Russians won't be firing any. But probably when one thinks of the proliferation of ballistic missiles and nuclear weapons to third world countries, it might be that something like SDI is more valuable now than it had been during the time of the Cold War. So just to be sure that some third world country doesn't launch a missile that could cause billions of casualties.
Brute force, the history of weapons at war, will continue in a moment here on A&E.
The stealth fighter, the Apache helicopter, the M1 tank, the Patriot missile. The incredible success of virtually every weapons system used by the coalition in the Persian Gulf War leads one to believe that this was the first conflict fought with weapons of the future.
But the real victory in Desert Storm was not based on the volume of firepower, but the volume of information. Desert Storm marked the first use of J-STARS, the Joint Surveillance Target Attack Radar System. J-STARS is a long-range air-to-ground radar surveillance system capable of looking deep behind enemy borders to detect and track enemy ground movements.
J-STARS enabled the Allied command to see where the Iraqis were deploying their forces. When the Iraqis started withdrawing, we could see quite clearly the 3 or 4 massive amount of vehicle movement, and therefore you could deploy your air assets to the maximum advantage.
It's been said that weapons are only as smart as the people using them. In Desert Storm, computer simulation was used to train many of the forces, training not just in the use of hardware, but also in the use of tactics.
One of the great successes of the Gulf War was the tremendous effectiveness of different forms of simulation in training, so that so many of the glitches that are normally associated with using a new weapon for the first time simply did not appear. Well, one of the reasons they didn't appear is that across all of the services, there had been a great deal of training in quasi-combat circumstances using the new equipment in an intensely hostile environment. Essentially, it can be best described as creating a battlefield in simulation, a battlefield of digitized terrain that you're not looking at through a screen. You actually go out and fight in a three-dimensional, full-up, totally realistic battlefield. That use of simulation, creating a very, very intense, full-up, kill or be killed environment, has revolutionized the training of all the armed services.
The boundaries of future military technology seem only limited by the astronomical development costs. But of course, no expense is as great as the loss of human life. In the future, the power of the microprocessor will also be applied to the foot soldier. Infantrymen will wear computer-equipped battle gear. These suits will be air-conditioned, fireproof, and will resist chemical, biological, and directed energy attacks. Helmets will provide a heads-up display with thermal imaging for sighting of their weapons. The soldiers will also be linked to command, control, and communication centers through their computer. Over the helmet display, they will receive battlefield status, as well as on-the-spot training and field diagnosis and maintenance. A generation beyond the protective battle gear will be exoskeleton suits, computerized armor-plated uniforms, which will multiply the soldier's physical strength and stamina. Of course, this presents the possibility that the man can eventually be removed from the armor, and a robot will fight the battle. Perhaps future conflicts will become so technologically advanced that human beings will no longer be needed on the battlefield. In Desert Storm, Pioneer unmanned air vehicles served a valuable role in target acquisition, reconnaissance, and battle damage assessment. Launched using rocket assist from battleships and ground installations, the Pioneers traveled deep into Iraqi territory to transmit signals from their television cameras and infrared sensors. Information received aided in the targeting of artillery and the battleship's giant 16-inch guns. In one instance, Iraqi soldiers surrendered to the Pioneer, knowing the thunder of the 2,000-pound projectiles wasn't far behind. In the future, more advanced unmanned air vehicles, like the Navy's Tracer, will perform many missions on the battlefield. Based on the Osprey tilt-rotor aircraft, the Tracer will require no special launch or recovery equipment.
Survivability is becoming more and more important in the use of any of these military armaments. Years back, maybe the battles were fought with serfs or with lower-class people and no one cared much about them, especially the upper class. But more and more these days, we care about our people, and we attempt to put them in a position of safety and security and fight the battle from longer and longer extended ranges.
Of course, the goal of our military leaders is to create weapons that will ultimately spare human lives. But if they need any reminder of the proper direction to take for warfare of the future, they need only listen to the voices of the warriors of the past.
To talk about combat and tell you what it's like is impossible. You don't think about killing a man per se, killing him. My reactions was just an object. There was a dark object out there right in front of me, and I had to pump 2 or 3 shots into it, which I did because I didn't think that I couldn't stop and think I might be killing some father or son. You can't think about those things. It's either him or you.
I think quite often it was a case of thinking in terms of dedication to a mission, quite frankly, an assignment, but never with a thought that it was devoid of a taking of a life or destruction of a life. And I think as you tend to get a little bit older, as time goes on, you tend to consider that more, and you come to realize even more that war is a hell of a way to settle differences. There's got to be a better way. Got to be.
Time and time again, we've seen the development of a new weapon that appears so devastating that we believe this will finally be the true deterrent to war. However, time and time again, we've been proven wrong. There seems to be no upper limit to how far weapons can progress, but we can only hope that as they evolve, the one thing that is rendered obsolete is war itself.
Now, stay tuned for a look at the undercover agencies who ensured the Allied victory of Desert Storm on America's Secret War, next.